You ever wonder how your favorite streaming service just knows what you want to watch next? Or how a bank can track millions of transactions perfectly every single second? Well, the answer is the database. It's this powerful, unseen engine that's running pretty much our entire digital world. And today, we're going to pull back the curtain and see exactly why it's the absolute bedrock of data science. Okay, let's get into it.
So here's the game plan. First, we'll talk about the absolute flood of data we're dealing with. Then, we'll meet the heroes of our story, the database and its manager. We'll look at what they actually do, how they organize everything, and then wrap it all up with why this matters so much, especially for data science.
All right, so before we had these really slick systems, we were just drowning in data. I mean, can you imagine trying to run a business with critical information just scattered across hundreds, maybe thousands of separate, totally unorganized files? It was pure chaos.
And that was the fundamental question everyone was asking. How do you take this constantly growing ocean of raw facts and turn it into something you can actually use, something you can search, and most importantly, something you can trust?
You know, this right here shows the huge leap forward we made. The old way, just using file systems, was a mess. You'd have tons of copies of the same data, which of course created all sorts of inconsistencies. Information was trapped, isolated in different files. Just finding what you needed was a nightmare. Then, along comes the Database Management System, or DBMS. It created a single source of truth, giving everyone access to the same, consistent data. Game changer.
So let's properly introduce the two key players that bring some much-needed order to all this data chaos. That's the database itself and its absolutely essential manager.
First up, the database. Now, this is not just a random pile of information. The key word here is organized. It's a methodically structured place for data. And the library analogy? It's perfect. Every single piece of data has a specific logical place, which makes it incredibly easy to find and to use.
And, if the database is our library, then the DBMS is our super smart, hyper-efficient librarian. It's the software that does all the heavy lifting. It organizes the shelves, it checks data in and out, it decides who gets access, and it just keeps the whole operation running smoothly.
So what's our librarian doing all day? Well, you can think of it in 4 main stages. First, defining. It sets the rules for the whole library, like what kind of information is allowed and where it's supposed to go. Then, constructing. It actually builds the shelves and puts the data on them. Next, manipulating. This is when it helps us find things, update information, and check things out. And finally, and this is huge, sharing. It lets lots of people use the library at the very same time, without them tripping over each other.
But a great librarian does way more than just organize books. Beyond those main jobs, they have some really critical duties to make sure the library is reliable, secure, and trustworthy for everyone who uses it.
These services are really the secret sauce of a good database. Data integrity just means the data has to follow the rules, right? No letters in a zip code, for example. Concurrency control is what stops 2 people from booking the exact same airplane seat at the exact same time. And of course, you've got security management to keep the wrong people out, and backup and recovery, which makes sure that even if the whole system crashes, your data is still safe. This is what makes a database so incredibly reliable.
Let's zoom in on transaction management for a sec. Think about a simple bank transfer. You need 2 things to happen, right? Money has to leave one account, and it has to arrive in another. The DBMS makes sure this happens with a set of rules we call ACID. Atomicity means it's all or nothing. The whole transfer happens or none of it does. Consistency ensures the data is valid before and after. Isolation means 2 transactions happening at once don't mess each other up. And durability? That means once it's done, it's done. It's permanent, even if the power goes out. That is the guarantee.
Okay, so we know what a DBMS does, but how does it decide where to put everything? Well, just like a real library needs a floor plan, a database needs a blueprint. And in this world, we call that a data model.
This blueprint, the data model, is the whole conceptual structure. It's the master plan that defines how data is organized and, crucially, how different pieces of data relate to each other. It's basically the map for our entire data library.
Now, the early blueprints were a little rigid. The hierarchical model was like a family tree, very strict parent-child relationships. The network model was a bit more flexible, kind of like a web. But the real revolution, the big one, came in 1970 with the relational model, which organizes everything into simple but incredibly powerful tables. And this was the moment that changed everything.
E.F. Codd's idea laid the foundation for almost every modern database we use today, from your bank system to your favorite social media app. It just made managing data so much more logical, flexible, and intuitive than anything that came before.
And here's a quick peek at why that shift was so important. The old models were just so rigid. The hierarchical model was a tree. Every piece of data could only have one parent. The network model was better, but both were a nightmare to design and required a ton of programming. But the biggest problem was this thing called structural independence. With the old models, if you changed the database structure, you pretty much had to rewrite all of your applications. The relational model's flexibility fixed all of that.
Okay, so we've covered a lot. We have our organized library, we have our super efficient librarians, so let's bring it all home and talk about the payoff. Why does all of this careful, painstaking organization matter so much in the real world?
Well, the payoff is huge. Organizations get one central source of truth that they can actually count on. Developers can build apps without having to worry about the messy details of data storage, which makes their jobs way faster and easier. You get better security, more consistent data, and you spend way less time on maintenance. It is a win-win-win across the board.
And this right here brings us to the main point of all this. Having a reliable, consistent, and accessible source of data that isn't just a nice technical detail. It is the absolute foundation upon which the entire field of data science is built.
I mean, this quote from our source material just says it all perfectly. You simply cannot find meaningful insights if you're building on a foundation of chaos. Data scientists need a well-managed database to store, organize, and pull out the massive amounts of data they work with. It's literally step one for everything else they do.
And in fact, if you look at a data scientist's job, a huge chunk of it is pure database management. Things like designing the data model, ingesting and optimizing the data, making sure it's secure, these aren't side quests. They're central to the whole workflow. The quality of any analysis you do depends completely on the quality of the database work that came before it.
So, from scattered, chaotic files to the structured engine that's driving modern AI, the journey of the database has been absolutely incredible. It brought order to our digital world, but the flood of data is only getting bigger and faster. It really makes you wonder, as we generate information on a scale we can barely even comprehend, what secrets are we going to unlock with the next generation of these amazing data engines?